Okay, we're on to page 3, and it asks us to simplify this expression right here. So let's start by using the power to the power rule. We'll distribute this 2 in here, 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 and that 5 in there, there, there. So we got 4 squared x squared y squared, and then this negative x squared, well, that gets the 5. So we got negative 1, really, to the 5th. X, what's 2 times 5? 2 times 5 is 10. Y times 5, 1 times 5 is 5. Okay, so let's see if we can simplify this. Now, what's negative 1 to the 5th power? Let's focus on that. Negative 1 to the 5th. Negative 1 times 1 is positive 1. Times 1 is negative. Times 1 is positive. Times 1 is negative. So we got negative 1 there. It's negative 1. And then we got 4. That's 16. And let's bring, so we got, really, if you bring these together, if you multiply it, really, this is just negative 16. Okay, so we'll take care of that. Now let's bring the x together. We got x squared times x to the 10. Now this is the product rule where we add them. 2 plus 10 is 12, so we got x to the 12th. And now we have y squared times y to the 5th is y. 2 plus 5 is 7. So I'm just going to rewrite it nice and clean. 16x squared y to the 7th is our answer for this one. Right there. Okay, moving on to this other one, we need to simplify. Again, we're going to use the power to the power rule at the beginning. I got negative x to the 3rd power. Well, let's simplify down that. We got this is a negative 1 in front, so negative to the 3rd is a negative times a negative times a negative is a negative. So we got negative x to the 3rd for that part. Okay. Now let's do this part. We got to the 6th, because the 6 is going to make that a positive right there. So we got times x. Now what's 2 times 6? Because we're going to multiply it. Power to the power, you multiply, not add. 2 times 6 is 12, so x to the 12th. And that is all over, what's 5 times 4, because it's power to the power rule. 5 times 4 is 20. So we got x to the 20th power. Okay, let's simplify this a little bit. This negative will just move on in front here. I got x to the 3rd on top, and x to the 12th on top. That's x to the 15th. And we have x to the 20th on the bottom. Now, we can cancel off on top and bottom. How many x's do I have on top? I have 15. How many do I have on bottom? 20. So if I cancel all 15 on top, how many am I left with on the bottom? Well, I'm left with 5 on the bottom. So I got x to the 5th, negative 1 over x to the 5th. Don't forget that 1 on top. Once you cancel, it doesn't mean there's a 0 up there. There's actually a 1 as a placeholder. Okay, moving on to number 26. It says, in simplified, what is the value of the exponent on the x? So we just want to figure out what's the value of the exponent of x. Okay, we can do that. So first we're going to distribute this into the y there, the negative 2 there, the 1 that you can't see up there, and then this 3 right here. Rewrite this. So I got 4 to the 3rd. X, negative 2 times 3 is negative 6. Y to the 3rd, and then x all over x to the 9. Now remember, our focus is just the x, the exponent of the x. So let's bring these x's together. We're going to take this, because it's a negative exponent, and we're going to flip it to the bottom. That makes it a positive exponent. So this gives us 4 to the 3rd, y to the 3rd, all over x to the 9, x to the 6th. Now let's just bring these two together, and we will have our answer. This becomes 9 plus 6, which is 15. So we got 4 to the 3rd, y to the 3rd, all over x to the 15. So our solution is right there, 15. So the exponent is 15. Right there. Okay. Next, it says to evaluate 3 halves, or 36 to the 3 halves power. Let's take a look at that. 36 to 3 halves. Well, the best way to do this, there's a couple ways to do this. First, with this 2 on the bottom, what it's telling you to do is take the square root of this. What this 3 is telling you to do is to cube this. Well, let's start by taking the square root of this. We can do either order, it doesn't matter. What's the cubed or square root of 36? Well, it's 6. So really we have 6 to the 3rd power. So what's 6 to the 3rd power? Well, let's figure that out. Let's just get a calculator. 6 to the 3rd power is 216. 216. So that's how you can do this problem. But sometimes it doesn't work out that easily. Sometimes it's not as easy. So I'm going to show you how to put this in your calculator. Give me a second. Okay, so we've got to get out of focus here. So right here we need to put in 36 to 3s power. So I'll type 36. I'm going to raise it up to the, and some of you don't get this little box thing up here, see that? So what you're going to need to do is you're going to put parentheses. You're going to put 3 divided by 2, 3 halves power, like that, and push enter, and see how I get 216, right there, 216, okay. So that's how you can do that on your calculator. Okay, moving back. Next question is the relational function? Well, we know it's a function if, first, all the x's are different. So we just have to look at the x's. This is the x value, that's the y. This is the x value, that's the y. This is the x, and this is the x. Now, are they all different? Well, we've got 0, 1, 2, 3. Well, there's no repeats, so yes, it is a function. Okay, number 29 says, state the domain and the range of the function. So the domain, what that is, it's all the x values, all x. And then the range is all the y values. So really what we do is usually we use these little birdie things. And we're going to do the domain first. The domain we'll put our right here. And the domain, we want to write it in from least to greatest. So we got a -3, -2, -1, 0. So -3, -2, -1, 0. That's our domain right there. And let's find our range. We'll use those. And that's all these values right here. So we got a range of, well, we got a 0 and our 1. So our range would be put like this, 0, 1. You do not have to put any repeats twice. You just put it, if it's a 0, you put the 0 in once. Even if it's there a billion times, you put 0 once. So there's our domain and there's our range. Okay, moving on to number 30. It says let f of x be this and g of x be this, or 4x plus 12 for f of x and x plus 2 for g of x. Be sure to state any domain restrictions. So it really wants us to do these operations. It wants us to add the f plus the g, subtract it, multiply it, divide it down here, and divide it again down here, and state any domain restrictions, and we're going to run into that down in this area. So let's do that. Let's set this up. Okay, so f of x is 4x plus 12 plus x plus 2. So because it's the plus, we really don't need the parentheses here. We got 4x plus 12 plus x plus 2. Let's bring the x's together. That gets us 5x, and we'll bring, that's from those two, and bring the 12 and the 2 together. That gets us 14. Here's your answer. Move on to f minus g. So we got f of x, which is 4x plus 12, minus, we got to put this in parentheses, g is x plus 2. Now remember, I hate subtracting a whole parentheses, so what I do is I change it to a positive, and then change this to a negative, or the opposite, and this to the opposite, which should be a negative. Okay? You don't change this first one, just the second one, the second set of parentheses, okay? If there's parentheses there. So what I have now is 4x plus 12 plus negative x plus negative 2. Okay? So let's bring our like terms together. 4x and negative 2, that gets us 3x, and then 12 and negative 2, that gets us 10x, or just 10. There's your answer. Okay, now we're on to multiplying. In this situation, we got the 4x plus 12 multiplied by the x plus 2. This is where I like the box method. Let's do that box method. Okay, so we'll make our little box. It's a 2 by 2 box because I got 2 here and 2 terms there. 2 terms, 2 terms. I'm going to take this 4x plus 2, put it right here. Oh, 12, sorry. I'm going to take this x plus 2, put that right there. Now, it doesn't matter. You could put this up top or this on the side. It won't make any difference. So 4x times x is going to give me this. So I got 4x squared. 4x times 2 is 8x. 12 times x is 12x, and 2 times 12 is 24. Now I'm just going to combine like terms in here. Now we got 4x squared there. Are there any x squareds? Nope. So that's taken care of. I got 8x and 12x. When you combine those together, because those are like terms, what I get is, well, that's 12x, right? So I got plus 20x. And lastly, I got this 24. So plus 24, and there's my solution. Okay, so the next step is number D. Going to move on to D here. And then E. Here we got fractions. Actually, fractions aren't terrible. They can work out pretty easily for us. But let's see if we can simplify this. We got f over g. So really what we just do is take this f of 4x plus 12 and we put that on top. So we've got 4x plus 12 on top. And then the g, which was x plus 2, we put that on the bottom, x plus 2. Now we've got to ask ourselves, can we simplify this at all? Well, maybe we could pull a 4 out of this. If we factor a 4 out, it would be x plus 2. I don't think so. If we factor 4 out of here, we have 4 on the outside. This would be with x, and this would be x plus 3. in parentheses. X plus 3 doesn't cancel out x plus 2, so this looks like it's as good as it gets. Now the question that we have to do is be sure to state any domain restrictions. I said that up there. To figure out the domain restrictions, all we have to do is look at the denominator. Okay? Remember, when you divide by 0, things just don't make sense when you divide by 0. So what would you put into this to make this equal to 0? Well, what plus 2 is equal to 0? We can solve that. Put that over here. X plus 2 equals 0. Subtract our 2, subtract our 2. So we have x is equal to negative 2. So when x is negative 2, this function doesn't make sense. Thus, this is a domain restriction. Okay, let's do the same thing. Let's do it for g over f. So at this time we have g on top, we have x plus 2. On the bottom we have 4x plus 12. Okay. Again, this won't simplify down at all because the polar 4 out of here and here, then it can cancel anything else. So this is as good as it gets. Now let's figure out the domain restriction. What do we have to put in for this denominator into the x to make this denominator equal to 0? Because you can't divide by 0. Well, if you're not sure what it is, we just take this 4x plus 12. You set it equal to 0. So we subtract the 12, subtract the 12. So we have 4x is equal to negative 12. Divide by 4, divide by 4. And so we have x is equal to negative 3. So what is our domain restriction? Negative 3. Okay, moving on to problem 31 right here. Okay, so we want to let f of x is equal to x squared and g of x equal to 1/2 x minus 4. Oh, these are problems just like before. Okay, now we're just having an x squared term. So let's do this. X squared, that's our f right up there, minus, and then g of x is 1/2 x minus 4. So we have 1/2 x minus 4. Because of subtracting this, we have to deal with, we don't like that, we don't like subtracting with parentheses, I'm going to make it positive. When I do that, this has to be the opposite, and that has to be the opposite. So I have x squared plus negative 1/2 x plus 4. Can you combine any like terms? Nope, nothing to combine. So that's as good as it gets right there. Okay, let's do f plus g. That one, we got x squared, again, it's f of x, plus, we got 1/2 x minus 4, that's what our g of x is. We can't do much, we just get rid of the parentheses because we're not subtracting, so we have x squared plus 1/2 x minus 4. Last one we have f times g, so what we have is x squared, that's our f, times our g, which is 1/2 x minus 4. Okay, this we can make a box and multiply it, or we could just distribute it in there. I'm going to choose to distribute this time. So I'm going to distribute this x squared here to the 1/2 x and to the negative 4. Well, what's 1/2 x times x squared? Comes out to be 1/2 x to the third. And what's negative 4 times x squared? Negative 4x squared. Here's your solution right there. So these are your 3 solutions for this section. Okay, moving on to number 32. Guess what? Don't worry about this. I'm teaching this to you. I don't believe it's on the test, and if it is, I will remove it. So, and even number 33. Oh, but just so you know, this is what this stuff's talking about. We got absolute value of this, which would be 4.7. This tells you to round up. This is like a round up thing. It's kind of weird because I have a thing on the top, and this is just a bracket. So you just put 7.4 again, and here you got an absolute value in that. But we really didn't work with those, so we're moving on. Well, same thing goes for number 33. You don't have to worry about this because we're rounding up. Moving on to number 34. Okay, identify the transformation from the parent function, which is x squared, to the new function. Okay, so transformation, you know, if we think about transformations, remember that. Remember when we have our parent function looks something like that, that's our x squared. Our transformation either shifts it up, shifts it down, shifts it right, shifts it left, and it can even make it skinnier or fatter, like that. Yeah. Or it can even flip it upside down. That's possible too. It can flip it upside down. So those are the different types of transformations. Okay, so let's take a look at this one. Here we have g of x is equal to x squared plus 3. So our parent function was our x squared, and it looks like they added 3 to it. Now, you might not know what the transformation is for this one. So the best thing to do is to just grab your graphing calculator and graph it out. So let's put that in here. So we're going to put y, I'll turn it on, put y equals, okay. Well, that's what I like to do, is I like to start by putting the parent function in there, and then I like to put the transformation in there, x squared plus 3, and just see what happens. So we got this graph, there's that one, the other one is kind of hard to see, so we're going to zoom in a little bit. We'll just do a zoom standard. Should have set it up for that. Okay, there's the parent function, and here's the next one. Well, it looks like it just shifted up 3. So that's what we'll put down there. The transformation was shift up 3. And really, you know, it's shift up 3 because whenever you add or subtract in the outside of parentheses, you will move it up if it's positive or down if it's negative. Okay. So the next one is g of x is equal to negative x squared. Well, not sure what that or what that does maybe, so let's just try graphing it. So again, we have our parent function right here is x squared, and let's just put negative x squared for the other one and graph it. So we got our parent function right here, and our next function, oh, looks like it flips it upside down. And some people say that's flip over x axis. That's what that one does. So whenever you have a negative in front of the x, or maybe you might see this like this, negative x plus 2 squared, this negative right there will flip it over the x-axis. Okay, and then we got this next one. We have g of x is equal to 3x minus 2 squared. So let's just see what that looks like if we were to graph that out. We got y, so we got 3x minus 2 squared. And graph that out. So again, our parent function, minus 2. Oh, looks like it shifts it over to the right 2. The minus 2 maybe shifts it to the right 2 from that. And then it looks like it's skinnier. That 3, that multiplier makes it skinnier by a factor of 3. So how would you write this? You would say shift right 2. That's from that. I know it's negative, but it's right. It's the opposite of what you would expect for when it's inside the parentheses. And vertical stretch by a factor of 3. That's from that right there. Okay, so that's this one. We're moving on to chapter 3. Oh, we're plowing through this. Here it says solve a system of equations right there. Now remember, there was a bunch of ways you can do, actually 3 ways we can do this. One is substitution, another one is elimination method, and I think there's another one. What was the other one? Let's just use substitution and elimination. Those are good ones to stick with. So here we got x equals y minus 8, and 4x minus y is equal to negative 2. And maybe, let's just try using, how about let's do substitution in this situation. We know what x equals, right? We know what that equals. Let me focus this sucker. Okay, so we know what x equals in terms of y. It's given to us right here. So let's take this x, which equals this. We're going to, since this x is right here, and this x is also equal to y minus 8, we're going to rewrite this as 4y minus 8. That goes in for that x. Minus y, that's right there, equals negative 2. Okay, so we just plugged in the y minus 8 for that x. Well, let's distribute that there and there. So we got 4y minus 32 minus y is equal to negative 2. Next step, we're going to figure out, let's add 32 to both sides, add 32. So we got 4y minus y is equal to 30. And we'll subtract this, so we got 3y is equal to 30. Divide by that 3. So we get y is equal to 10. Now, I wish we were done. We're not done. We know what our y is. So we'll put that right here. There's our 10. Now we got to figure out what our x is. So what we're going to do, we're going to take this 10, plug it into either of these equations. This is the easiest one, so let's plug it into that one. So plug it in for that y right there, and what do we get? We get x is equal to 10 minus 8. Okay, we put that in for y, so x is equal to 2, and we take that and put it right there. So our system of equations is 210. Now remember, what we really figured out is if we were to graph this line, okay, and graph this line, what we figured out was where did they intersect? That's what we found. Okay, now these aren't the same 2 lines right here, but we found where they intersect. That's what we're looking for. That's solving the system of equations. Where do the 2 lines intersect? Okay. That's what I was talking about. Sorry you didn't see that. Okay, we got one more here. Let's solve this system of equations. This time, let's use the elimination method. Now this is how the elimination method works. The key thing is to get the coefficients for either the x's or the y's to be the same or opposites. And then you're going to add or subtract both of them depending on what they are. So thankfully we got the x's are opposites, the coefficients. This is 3 and this is negative 3. So how do we get rid of them? Do we add the 2 or subtract the 2? Well, in this case 3 minus negative 3 wouldn't do it. That would make it 6x. So let's add these 2. That will cancel them off. So 3x plus negative 3x, that's 0x. That's gone. 4y plus negative 2y, well, that's like subtracting, so that's plus 2y. And then 3 plus negative 9, that's 3 minus 9, so that's negative 6. So I got 2y equals negative 6. Let's divide by the 2, divide by that 2. And I get y is equal to negative 3. And I'll put that right here. Okay, so we got our negative 3. But we're not done. We need to figure out this x. So let's do that. Let's find the x by taking this and plugging it in. Or we can plug it into either equation. Doesn't really matter. Let's plug it into this top one just because I have room. So I got 3x plus 4 times negative 3 is equal to 3. So this brings us, so we have 3x minus 12, because 4 times negative 3 is 12, or negative 12, equals 3. Let's add this 12 to both sides. We've got 3x is equal to 15. Divide by 3, divide by 3, and we get x is equal to 5. Take that, put it there, and we get our solution. And that is the end of page 3.